Hello, this is Greg Allison with Galactic Gregs, coming to you with a broad survey of numerous anti-gravity technology projects. This is a comprehensive review of so many projects, it's going to knock your socks off. My friends, she actually had started a research institute to fund anti-gravity research. And let me tell you what, this review has several of the top propulsion engineers and advanced space program engineers that were available from the Marshall Space Flight Center. There's dozens in the room in here, and they're all listening intently and having very serious discussions with the lady in question. That's why this is interesting. They took it seriously. This was a very top-notch program with some of the best space professionals in the business. No woo-woo, no laughing. It was serious content. My friends, watch this. You're going to really enjoy it. And if you're not subscribed to my channel, subscribe, bang that bell, and hit all so you can get all the notifications, because I'm going to bring you a lot more exciting stuff on this channel. Just hold your socks and buckle up. It's going to get interesting.
Let's get right into it and talk about gravity. Just kind of to start with the basics. What is it basically? It's a fundamental physical force, interacts between different masses over both long and short distances. It controls the orbits of the planets, and those are all things we've heard before. And anti-gravity is basically the science of modifying gravity. So anti-gravity is kind of a misnomer. It's really more gravity modification, but colloquially it's called anti-gravity. So just kind of start at the beginning, right? So Copernicus published his theory of heliocentricity in the 1500s, and then Kepler, of course, came up with the planetary motion stuff in the 1600s, and then Newton published his law of universal gravitation in 1686. And I guess one thing to really note about his law of gravitation is that it follows the inverse squared law, meaning that it dissipates over a distance proportionate to the inverse of the square of the distance. It was measured first by Henry Cavendish in the Cavendish experiment. And then Einstein, of course, published his general relativity in the early 1900s. So that kind of leads us in, what does relativity have to say about gravity? So relativity says that gravity is basically a deformation in space-time. So sometimes you see those pictures of like a planet and then there's kind of a dip in space-time that it kind of sits in. And so relativity kind of says that anti-gravity is sort of impossible without negative mass. Some people would disagree with that, but that's what relativity has to say. And then, so the standard model of physics doesn't really include negative mass, so that's sort of a problem. So a lot of people talk about what you call unified field theory, which is there's four forces, right? There's gravity, electromagnetism, and then the strong and weak nuclear forces. And those forces are each mediated by a particle, so a photon, gluon, or the bosons. The graviton has been proposed, but never really been seen. So it's a proposed particle. And all of the other forces are unified, meaning that you have one theory that kind of agrees with all of them. But gravity is not unified, meaning that the theories that describe the other ones don't apply to gravity. And so it's kind of an incomplete picture, perhaps. And we all know that electromagnetism is quantized, magnetism is quantized. So a good question would be gravity, is that quantized too? And we don't really have a good theory for that right now, although some theories have been put forward. So I want to talk about anti-gravity research in sort of the early days, and start from the beginning. So this is a photo or a sketch from H.G. Wells' The First Man on the Moon book. So one of the earliest anti-gravity machines that was kind of put forward was the Thomas Townsend Brown's generator, or Brown's gravitator. That was in the 1920s. He coined the term electrogravitics, which you hear sometimes in the literature these days. an asymmetric capacitor here. So a capacitor where one electrode is larger than the other. And so that supposedly can create a thrust in one direction, but vacuum tests have kind of shown that that's perhaps ion wind and not the true anti-gravity effect. Sometimes you see these little, like on YouTube, sometimes you see these little foil lifters where it's like 3 sticks in a triangle and a piece of foil going around the top and then a thin wire going around the bottom. And that's kind of the same basic thing where it's an asymmetric capacitance thing. Some people call those simple anti-gravity lifters, but really those are just ion wind as well. They don't work in a vacuum. And then of course Nikola Tesla did a lot of work in this field. He had what he called the space drive. And this is one of his sketches of a vehicle that he proposed putting his space drive into. And so he patented that, the patent number's there. He called it anti-electromagnetic propulsion. And he talked a lot about electropulsation. And he had what he called the dynamic theory of gravity, which was really more of an ether theory, where he talks about ether filling all of the space, and he talks about mass being really just little vortexes of the ether. And then he says that, you know, as a particle decays, it's really just the ether kind of spinning down or not vortexing quite as fast and then dissipating. And he totally rejects the notion of curved space-time. So that relativity example we were just talking about you have the planet kind of sitting in the curved space-time. Tesla doesn't agree with that really at all. In 1948, the Gravity Research Foundation was founded by Roger Babson. He started an annual essay prize where you would write an essay on gravity and then he would give, I think it was like a $4,000 prize at the time. And that prize has been won by many famous scientists. Stephen Hawking is one of them. 5 Nobel Prize winners have won the Babson Prize. Some of those essays are sort of in favor of anti-gravity being possible, and some of them are more critical. So this is actually an essay that won in 1953 by a scientist named Gyroscopes, and he was kind of talking about, just to paraphrase this, is you kind of need a good theory before you can really make a working device, is what he's kind of saying here. We don't really have the theory, so why do we have devices that we say work? So he's saying we're a little ahead of ourselves on that. So then in the 1950s, there were several government and government contractor programs. So there was something called the Aeronautical Research Laboratory, which is now called the Aerospace Research Laboratory. And they supposedly conducted many anti-gravity experiments on the Wright-Patterson Air Force Base in the 50s. And perhaps may still be involved with that now. And then there was the Research Institute for Advanced Study that later turned into Lockheed Skunk Works. In the 1940s, there was the Searle generator, and that was purported or claimed to be a combination of anti-gravity and free energy. It's kind of this like metallic, you've got like a magnetic ring and then an insulator ring and then like a copper on the outside. And there's these little cylinders that rotate. And the thing does rotate around and it makes a lot of noise and it appears to do something, but it's been sort of widely panned, although it's still in development with some modern efforts. There was the Dean drive in the 50s and 60s. This was claimed to be a reactionless drive, meaning that there's no propellant exhaust coming out as you thrust forward in one direction. It was basically like they have kind of a asymmetric weight thing that's asymmetrically kind of oscillating around, and it creates kind of like a linear oscillation. And a lot of people think that effect may be actually just due to the friction of the thing oscillating back and forth, and then the friction just kind of pushes it forward. So that's probably just an effect of friction. There was the Wallace machine in 1968. This one was patented. It's basically some spinning brass discs, and brass is 1/2 integer, nuclear spin. And so the idea of this is that you spin the metallic around, and it's supposed to align the nuclear spin. And then, he calls it the kinematic field. So he talks about the motion of metals, and he really gets into like the kinetic part of aligning the nuclear spin. Again, this one is unsubstantiated. There's a lot of people that talk about this was patented and then kind of fell off the map. And so sometimes people talk about maybe it went black or was kind of taken under, but it's also just kind of unsubstantiated. There's the Laithwaite gyroscopes. So Eric Laithwaite was widely known as the father of maglev. His hypothesis was that these rotating spinning disks could create a force that's orthogonal to both the spin and direction. So if you look at this thing here, it's spinning on this axis, and then it spins on this axis as well, and then the force is in, I guess, this direction. So he had these big gyroscopes that he would like hold up over his head, and they were really heavy, and he would like hold it really effortlessly looking. And he did a lot of kind of interesting public displays of his, swinging his heavy gyroscopes around his head and that kind of thing. And so he made kind of a splash with that, but it maybe can be accounted for through centripetal forces and Newton's second law explaining the effect. So it's kind of a cool and maybe a useful effect, but it's not necessarily true like anti-gravity or gravity modification. So I was going to talk a little bit now about the modern efforts. So in 1973 there was the Mansfield Amendment, and this restricted DoD dollars from being spent on non-military applications. So things like propulsion, or anti-gravity propulsion kind of fell under that umbrella. And so this kind of means that we're not really doing anti-gravity research in the public sector of the government anymore at all by legislation. And so kind of the explanation at the time was, well, this stuff doesn't work, so we don't want to waste money on it. But maybe another explanation is that they had their own black budgets and they didn't want to double spend on their other projects, so they just legislated that they couldn't do that anymore. So I don't know, there's different interpretations of what was going on with the Mansfield Amendment. In the 1970s, there was this guy, John Hutchison, who he's like all over. You can find videos of him on YouTube, like supposedly levitating things, and he was really trying to replicate Tesla's work. He was really big into Tesla, and so he noticed these anomalous effects when he was playing around with Tesla coils. And he claims that he replicated the Philadelphia experiment, which is of course the experiment where the ship like disappeared and then reappeared. So so he had these like this is a picture of a bar of metal that he supposedly could focus his machine on a metallic object, and it would just kind of like melt and twist down into itself. And then you would touch it and it wouldn't be hot to the touch. So there was no heat, but it somehow was rending the metal or deforming the metal in some way. And then he claims that after he did this successfully for a long time, that he started getting attention, and then people came in and started trying to get him to replicate it, and he lost his ability to perform the experiment, which kind of means you can't replicate it, right?
I saw one of those beams one time.
Yeah, my dad actually saw one of those.
Yeah, the guy at Halfway Lab showed me one. It was a 6x6 beam. It was split down the middle and then twisted like it was taffy, but it didn't look like it had ever been hot.
Yeah.
He had it mounted on a plaque. He brought it out of his office and showed it to me. He did experiments with Hutchison.
Yeah, so Hutchison is affiliated with the Hathaway Lab in Toronto. And they do have a lot of these metal pieces that have these weird deformations in them, but it's unclear exactly how that happened. And if you ask Cal Puthoff what the cause of it was, he'll say, oh, I just think that guy was telekinetic.
He said it was telekinetic. Because this guy, according to these guys, he would sit there in his basement and he had these radio transmitters and Tesla coils and all this stuff, and there was no theory behind it. And he would sit there and adjust the knobs and do this and do that, sometimes for hours at a time. And then eventually, after an hour or two, weird things would start happening.
Yeah.
And so Hal thought that he was just telekinetic.
He just focused on it for hours
And
until it
that
happened.
he wanted it to happen so bad that it just happened. And
Yeah.
the strange thing about it was he was agoraphobic. He didn't want to go outside.
Yeah.
So he stayed in his basement all the time. But when people found out about his effect, they wanted him to come out and show it to people. So they took him to a psychologist and he gave him some pills for the agoraphobia. And they said that after he started taking those pills, he could never do it again.
So that's the loss of ability where he was suddenly not able to replicate it anymore. So
Yeah.
according to Hal, it's because he was a telekinetic, but Hal believes in those things, so take that with a grain of salt.
It's an interesting story anyway.
It's an interesting anecdote. So then in 1990 there was the Woodward effect. So Jim Woodward is known as sort of the father of the Mach effect. So sometimes you hear about the Mach effect in like popular literature. But so this is another reactionless thruster, kind of like the Dean drive was a reactionless drive. So meaning that you get thrust, but there's no propellant coming out the other end. So he said that this would enable basically a warp drive where you have a large negative mass and then it warps space-time. And then what you have here is something called an Alcubierre plot.
Alcubierre.
Yeah. And so this is supposed to be like a compression and an expansion of space-time that basically causes it to like travel in one direction. So this part is kind of interesting. So in the 1990s, we actually had quite a bit of sort of anti-gravity research that was done here in Huntsville. And there was a UAH scientist named Ning Lee, and she worked with a grad student named Doug Torr. This is Ning Lee here, that's Doug Torr, and that's he was the chair of the physics department, that's Larry Smalley. And so she theorized that if you had a magnetic field on a superconductor, that it would align the ion spins in the ion matrix of the solid state ceramic, that it would align the ions and produce this gravito-electric effect. And so Popular Mechanics did an article on her. NASA got involved and they did a collaboration in the late 90s. And then she actually left UAH and founded this company called AC Gravity LLC. And that was in 1999, and if you look for her company, it's still registered, but no one really knows what they're doing. And she got a $500,000 DoD contract in 2001, and then it kind of ended there, and we'll talk about that more in a second, maybe. Oh, okay, yeah, so what happened to Ning Lee? So if you Google what happened to Ning Lee, just Google that sentence. It's kind of like a weird internet legend that has originated out of Huntsville. This is a Reddit post under our conspiracy talking about, hey, what happened to Ning Lee? Why did she get DARPA funding and then disappear? So that's just kind of an interesting internet legend that has come out of Huntsville.
She had 2 other graduates.
Yeah, I've talked to some of them. I've run into people even outside of Huntsville in the sort of weird science anti-gravity community, and when they hear I'm from Huntsville, they're like, oh my gosh, Ning Lee, what happened to her? Tell me. And I'm like, I don't know. I don't know what happened.
She was a member of HAL 5 for a while.
Yeah. Yeah, I've talked to a lot of people that have worked with her.
We took a tour of her lab.
Really?
Back in 1997 of the HAL 5 sponsored event.
Yeah?
Yep.
Well, if anyone knows what happened to Ning Lee, I would like to know.
I heard she went up to Maryland, around that area.
I've heard that. I've heard 3 different stories about Ning Li. I've heard that she got breast cancer from handling the toxic chemicals with the superconductors without gloves, and that she died in the U.S. I've heard that she went back to China and died there of breast cancer. I've heard that she just got sucked into the DoD and has been doing DoD stuff quietly ever since. And I've heard that she went back to China to get funding because she couldn't find funding in America, and so she's working in China now. There's a lot of different stories about
Doug Torr went and founded a company.
Yeah, I've got a slide on that here in a second. So kind of related to the Ning Li thing is the Podkletnov effect. So this is a Russian scientist who, really within just a few years of Ning Li publishing her first paper about superconductors and gravity, he started doing this rotating YBCO disk. And YBCO is kind of interesting because it was actually invented out of UAH by a grad student, and it was famously stolen by another university and patented within like the next day of it being revealed to his professor. The next day he went to another university, was suddenly chair of the department, and was filing a patent for YBCO literally the next day.
So what's YBCO?
It's yttrium barium copper oxide. It's a superconducting material. It's one of the more high temperature ones. It was invented at UAH.
Same stuff Ning Li used, right?
Huh?
That's the same stuff Ning Li used.
Yeah, Ning Li was using YBCO, and then Podkletnov kind of picked up from there. Who?
The guy that invented YBCO.
He's on my LinkedIn. I forget his name, but
He's got a little statue.
yeah.
I know.
I would love to talk to him actually.
I might be able to find him. I was a graduate student that worked with him.
Oh, really?
It's amazing how much hype that project got.
I know.
And how little results it really produced.
Yeah, the Poher article really kind of put it out there.
Well, I used to read stories in the paper about what we were doing
Yeah.
and watch CNN interviews.
And you'd be like, oh,
And I was right in the middle of it going, yeah, I'm Mr. Claude, because I know everything.
Yeah.
Wasn't his name Doug Torr, wasn't it?
Doug Torr, yeah.
Yeah, he was the one that invented it. He, I think,
Yeah.
there's a, Richard's saying there's a plaque there at
There is a
UAH
plaque.
somewhere.
Does anyone here know Robert Becker? Because he worked with her as well. Robert
No,
Becker?
name.
Do you remember him?
was her student.
Yeah, Robert Becker did a quantized gravity thing where he took Maxwell's equations and then he kind of applied them to gravity, and quantized gravity kind of analogous to how you would electricity. And his thesis is over at UAH. And it's not on PDF. I had to like go and take a picture of every single page of his thesis.
It's only been checked out twice, right?
Oh, I checked out Robert Becker's thesis at UAH, and it's only been checked out twice. It was checked out in 1999 by the DIA Interdepartmental Library Loan System, and then it was checked out by me last year. But yeah. So the Podkletnov effect, rotating YBCO superconductors produces supposedly gravity shielding. And the kind of funny story about this is that he says that this was discovered because he was playing with superconductors trying to do something unrelated to gravity. And then a guy, one of his collaborators, walked into the lab and he was smoking a pipe, like a tobacco pipe. And the smoke drifted over the superconductor where the experiment was, and supposedly there was like a vortex in the smoke up over the superconductor. And so they started looking at kind of like what force is making that vortex in the smoke. And they investigated further, and they decided they thought it was a gravity wave or a gravity beam going up and perturbing the smoke above the superconductor. But he had a 2001 patent. He actually did collaborate with NASA Marshall Space Flight Center in the early 2000s, and the story goes that he came over here and we didn't pay for his travel in time, and he got pissed off about it and didn't want to come back anymore. But he claimed a 2% reduction in weight, and he was sort of like widely panned by the community. It was kind of a big splash when he first came out, and then a number of people, well, a small number of labs have replicated or attempted to replicate with varying degrees of success. There have been some near replications done by this guy, Claude Poher, in France. And I've got a slide on him here in a second. But so Doug Torr and Jose Vargas, who was also at UAH here briefly, they actually then went to after the Ning stuff kind of wound down, they left and they went to the University of South Carolina, and they created basically their own gravity beam generator. And they talked about it being an inhomogeneous electric field. So they have like 2 electrodes, like one could be a sphere or like a hollow cone, or that they talked about different shapes of electrodes, but the idea is that they're asymmetric, so like one is different than the other. And then they've got a website called Experimental Quantum Gravity, which is still online, although it's unclear what their professional activity is or what they're still working on. It's kind of unclear, but their website is still up. And then Tamir Data was their collaborator with that, I think, at the University.
I think they were awarded a couple of SPIRs and then they disappeared.
Yeah, so there's some evidence that they got some funding through an SPIR and then they kind of fell off the map just like Ning
Is
did.
that out of a patent, that picture?
Huh?
The picture out of a patent?
Yeah. Yeah, that's a picture of one of the conical electrodes.
Jose Vargas actually came to NASA and pitched it to MSFC management, and he drew that picture on the wall in front of us. And he was talking about Kinslerian mathematics.
Kinslerian.
He used all these strange symbols, and nobody knew what in the heck he was talking about.
Yeah. Robert Becker is one of the 12 people in the world that can read a Jose Vargas paper and understand what the heck he's talking about.
He also applied to be the director of our lab there.
Oh, Jose?
Rogers got it. Is that him?
Oh,
He applied for that position.
Becker did?
No, your Jose Vargas.
Oh, okay.
So the whole superconductor thing in general has been sort of widely panned and then abruptly dropped. Right, so the Ning Popular Mechanics article, if you try to Google it, you cannot find it. It is not up anymore. You can find some other blogs that have reposted it, but it's no longer officially up. Doug Torr's research was never made public by the university. Podkletnov, of course, was ousted by the University of Tampere almost immediately. And then Giovanni Modenese, who was Podkletnov's collaborator, I noticed last night I was doing some research and his Wikipedia page has been deleted.
I have a lot of that.
Huh?
I have a lot of that.
Really?
In fact, I got an interview of Podkletnov on VHS.
Yeah. I've seen some interviews with him, and he talks about the smoke story and the superconductor thing. And there's also this book. I was at a sci-fi conference a couple years ago called Dragon Con in Atlanta, and they had a sci-fi bookstore booth in the marketplace, and they had a whole bunch of science books. And I bought this book called Bogus Science. And then years later, I was flipping through it, and they were talking about Podkletnov, and they even mentioned Huntsville and the fact that Podkletnov had come over to Huntsville, and that they talked about Ning, but they didn't name her directly, but it was obviously talking about her. And so there's sort of maybe some kind of undercurrent of let's go discredit this for some reason, either that or it really was bogus. It's hard to tell.
I think the gravity probe beam people felt threatened by it.
Really?
And they didn't want any funds diverted over that. So it was. They felt threatened by her paper. They felt threatened by her paper. She even went and talked to them about the paper and told them basically told them that when they did their experiment, that they're going to find a result that would occur because of their spin superconductor involved in there. And I actually believe that happened. It was never really reported. I know you.
It was Jim Ashburn.
Jim Ashburn.
Jim
Right?
Ashburn, yeah.
Mm-hmm.
He lives here in town.
Yeah.
I would love to talk to him. But yeah,
Nelson knows.
I would love that. Yeah, I found him on LinkedIn, but I haven't talked to him. Okay, so Claude Poher in the 2000s. He's kind of like the only lab that has somewhat successfully done Podkletnov-like stuff and actually published, right? So he has sort of a modified Podkletnov experiment where he does the YBCO. I think his doesn't rotate, it's just static, and is YBCO, and he claims to get a propelling thrust out of the superconducting disk. And so this is a picture of a liquid nitrogen dewar with the superconductor down in there, and he, actuates or triggers the emitter, and the dewar basically explodes from whatever force is caused by the superconductor, some kind of force coming out of the superconductor that explodes the liquid dewar. And this was actually tested at NASA Marshall Space Flight Center in 2015, which has not been published. My dad did that, and they received very similar results where you can trigger the superconductor, and there is some sort of explosion that comes out of the superconductor, but when you take the disk out and look at it, it's totally undamaged. So the dewar around it explodes, but the disk is undamaged. So whatever force is coming out of it comes out of the disk in such a way that it doesn't blow it up. It's kind of weird.
Yeah, we took the tested them in mini buckets from Walmart because we blew up glass dewars. Blew them all over the lab, and it cost too much. So.
That's kind of an anomalous effect that those results kind of need some more explanation, or exploration, just to kind of figure out what's going on there. And then one of the more recent anti-gravity devices or experiments would be Morningstar applied physics. So some of you have probably met John Brandenburg and Paul Murrand. So they have this company Morningstar, and they have what's basically a modified Searle machine. So we talked about the Searle machine a little bit earlier. Brandenburg talks about his gem theory, which is this gravido-electromagnetism theory, and they claim a 7% weight reduction. So you can see it's very similar to the Searle generator that we looked at earlier. It's got the rollers, and they magnetically rotate and all of that, but they also, kind of the different part about this one is that there's actually a ferromagnetic fluid inside the center disk here, and I think it's actually just vegetable oil with some iron shavings in it, is what I heard. But so they claim 7% weight reduction, and then kind of the rumor that they're sort of privately claiming is they're now claiming 20% weight reduction, but I'm not so sure they're actually getting 20%. So there's, of course, the more well-known ones like Boeing Phantomworks. So this Gravity Research for Advanced Propulsion, or the GRASP program, has been around probably for a while, but they admitted to it publicly in 2014, is when they sort of admitted they had that program. I was reading there's some chatter about maybe Podkletnov being involved in this. I'm not sure if that's true or not, but I was sort of hearing that. And then, so these are so Phantomworks is where you get these black triangles that people talk about sometimes. So if you're into like the UFO scene, MUFON has a lot of reports of these like black triangles that people look up, and they just see like a black triangle blocking out the stars in the sky. There's a lot of reports of things like that. And that is supposedly the TR3B black triangle, and sort of the rumor is that that's what you call an ARV, which is an alien reproduction vehicle, which is sort of like meant to look like a UFO, but isn't really one because it's really from Boeing. So, and the mechanism maybe resembles a Brown generator. I don't know, it's hard to get information on. And then, of course, you have recent declassifications. So in December 2017, some of you may be aware there was a big declassification of several different documents Most of them related to this ATIP program, the Advanced Aviation Threat Identification Program. And that was, if you're familiar with like the To the Stars Academy, they did a lot of media promotion around these declassifications. And so like, here's two examples of some documents that were declassified. This is a Defense Intelligence Reference document. This one is on traversable wormholes, stargates, and negative energy. And this one is titled Warp Drive, Dark Energy, and the Manipulation of Extra Dimensions. So these are DIA documents that were actually released.
Who are the authors?
Huh? The authors? It's right there, but I can't read it.
Hal wrote one of them.
Hal wrote one of them. I don't know who the other one
Yeah,
was.
because Hal's group over in Eric Davis, being primary scientist, wrote a lot of stuff.
Yeah.
So,
Hal has written, there's a bunch of these DIRD documents that Hal has written. I've got a bunch of them on the
Hal wrote one about how if you could manipulate space-time, then you could essentially fall towards any direction you wanted to fall.
Yeah.
And that it also affected time, which would make a UFO difficult to shoot down because
Yeah.
the bullets come at them, but they have all weight to do something about it inside the craft.
Yeah, Hal talks about the space-time bubble around the craft, and so it looks like they're going really fast, but to them inside the ship, they're going at a normal speed. So it's kind of like dodging bullets in the Matrix.
And when the air comes through them at hypersonic speed, it goes into the time field, and the air doesn't seem to be moving at them so fast, and that's why there's no fluid friction,
Yeah.
according to
According to
his document that he
and
wrote.
news documents, yeah. So these are kind of interesting. There's some kind of funny, cartoons and some of them of like wormholes and stuff. They're kind of interesting to look at. So the future, what's the next step for anti-gravity? We've looked at a whole bunch of different devices of like varying credibility. So how are we going to get to the point where we have credible anti-gravity? And I have a picture of Huntsville here because you might as well do it here. I would think. So in conclusion, what now? We kind of need theories with testable hypotheses. That was what that Bryce DeWitt guy said, right, for the Babson Award. He was talking about, hey, we're kind of ahead of ourselves here. We need good theory so that we can test it and see if the theory's right or not. So we really need to focus on like the quantized gravity, is that a thing or not, and figure out the theory and then go build something. We think we need independently funded research because when you're at a university or an academic institution and you want to work on this stuff and they say, oh no, that's fringe, you can't do that. Or you have a result that you want to publish and they say, oh no, that's crazy. And then so that suppresses a lot of publications that maybe are accurate, but they're perceived badly and so professors are afraid to publish it. But if you had a privately funded research institution, you can just study whatever you want to, and you don't have to worry about tenure. So the other thing is promising results always seem to disappear. So like,
can you build an antenna which will be able to receive frequencies with wavelengths of 10 to minus 29 meters? Now, sir, those frequencies do exist. All we need is an antenna.
yeah.
And if we build an antenna and add rectifier to it, we will get lots of DC current.
Yeah, so you're talking about like the high frequency gravity wave
Correct?
antenna.
But high frequency,
Yeah.
I don't need just ultra high like gamma rays or something.
Yeah.
But wavelengths of 10 to minus 30.
Well, if you're familiar with Ray Chow, he talks quite a bit about gravity wave transducers using superconductors as basically a gravity
Those are still
antenna.
operating in nanometers.
Yeah.
We are talking about 10 to 30 is a distance between molecules and nuclear. Electron and nucleus. So we need that antenna.
Yeah.
Because where does the energy come from which keeps electrons spinning around nucleus
Yeah.
without slowing down at all?
Well, yeah,
Those
that's-
are the ones with the energy, those are the antennas which somehow rectify frequencies coming from outer space and provide the propulsion thereby.
yeah.
Now, some of those electrons obviously quit spinning. And what happens? Can you name an element that has nucleus only and no spinning electrons around it? Can you name that element and where does it exist?
Well, that would just be a proton, I guess.
Well, a neutron will decay in 11 minutes, I think.
Well, every atom, every element we have today contains a nucleus and at least one electron spinning around it. Can you name an element which ain't got no electron spinning around it? And where does
A
that?
neutron has no
Plasma.
electron spinning around it, but it has a
How
half-life
much
of
does
11
that thing
minutes.
weigh per cubic centimeter?
What does it weigh?
Correct?
1,800 times the weight of an electron.
Typical atom or molecule is full of free space.
Right.
Now, if you ain't got no free space, everything has collapsed in the nucleus. How much does that weigh per cubic centimeter or cubic inch?
Well,
Hundreds and hundreds of tons. And that is called black hole. So when an element
well, they can't even
dies,
tell
it
you how
becomes a
small
black
an
hole.
electron is. It's-
So now, when you want somebody to look into those exotic sciences, come up with a design that detects very, very high frequencies in wavelengths of 10 to minus 30.
I think that's a great idea.
Well, that does exist already, and furthermore, you can detect it.
Well, I
Not
have
detect it, rectify it.
Yeah. Okay. Well, they have like the LIGO thing, right?
No, that is called permanent magnet.
Oh, yeah.
Permanent magnet is nothing more than a rectifier of extremely high frequencies.
Yeah.
And that now, because it rectifies it, there's a circular current around it. And circular current obviously causes a magnet to exist. Now, if you are looking for some exotic science, why don't you fund me? I will start researching it.
You should come talk to me about it. Yeah.
Do you know anything about James Woodward's work?
James Woodward? Yeah, so that's the Mach guy. And, yeah. So I met him in September, actually, in Estes Park. There was a propulsion conference. Tony and John Cole and I were there. And he's nice. That was his like personal conference where it's like basically the groups that work with him and then the groups that try to disprove him. It was kind of funny actually because it was like it was the groups that try to prove him right and then it was the groups that try to prove him wrong. And it was a conference just for like 40 or 50 people that fall in that category. But yeah, I'm sort of familiar with his work, but I know that he only ever gets like a micronewton of thrust. He never really gets that
Yep.
much.
But that's just about every single one of them. They're all getting these very small bits of thrust.
Yeah.
So it's hard to say that if they're getting anything out of it, or is it just some sort of secondary effect of something else, like let's say with like the one with the Russian scientists who saw the smoke going up. You know that could just as easily been a current or a vortex.
Okay.
You know, because they got a really cold mass. They got some liquid nitrogen lying around, and that could actually be causing convection currents.
Well,
It was outside the chamber, it wasn't.
yeah, well, he claims that it was like even like a floor above the lab that you would get this deflection.
But it's still a cold spot. There would still be a heat gradient in there because it is much colder than the outside environment.
Yeah, I mean, there's been alternative explanations for like the Poher effect, which is kind of, you know, going on the Podkletnov thing. There's some people that would say that, oh, the explosion is just the liquid nitrogen vaporizing. So there's alternative explanations like that.
Now I do know that they're developing gravity sensors for mining operations because
Yeah.
because you can, they want to get it down all the way down to like, to a precision of 1/1000000000 of a G, so they can pick it, so they know if there's like a deposit of oil or iron in the ground. Now, I was wondering why couldn't they use something like that for these experiments? I mean, if they really are really affecting gravity in that, and if they're really having an effect on gravity, these things should be going off like an alarm bell.
My answer to that would be, why don't they do something like that for that experiment? Because no one funds it. That's why they don't do that.
These gravity meters that you're talking about, they tend to set them down and there for days or hours at a time for, just to see the gravitational shifts and things. We actually had one at Marshall and found out very quick that it was worthless to us because we were looking for stuff that was happening in milliseconds, not something that's happening over hours and days.
Okay. So the frequency is real low for those things. Okay.
My recollection of the Ning original work was that it was claimed that above this spinning disk there was a reduction in the gravitational attraction.
Right.
Even several floors up in a building.
Yeah, Podkletnov said the same thing. Yeah.
And that caused, we have a lot of debates about things about space science, like this was all going on, and that caused a number of people to, including myself, to say, you know, this would be really neat because you could make the equivalent of a simple water wheel by taking a bunch of rods with large mass on them, put a mass above the spinning disk, and then on the next floor the same kind of thing. You could run a generator and produce electrical current from one of them to continue driving the device, and then all the rest of them above would be producing electricity without having to spend anything. So it would be a way of generating large amounts of energy for free.
Right.
So that was one of the problems. This kind of a conundrum, an apparent production of a perpetual motion machine caused us to have problems with the Ning original results.
My understanding of the Ning like sort of roadblock, and maybe you can tell me if this is accurate, but I heard that she was trying to make the discs too big and that they would crack all the time. And that she spent all her time trying to make these big discs and they kept cracking instead of just making some smaller ones and getting some results.
We did make some smaller ones.
Oh, okay.
But she really focused on it because I think that she was looking for results, and let's be honest, you're looking for money.
Yeah.
And the only way you get more money is you have to find some kind of results for people to hang around.
Yeah.
Her theory was if you go to a bigger disk, you'll see more results.
Bigger results, yeah.
Can you tell us exactly what kind of measurements were made to quantitatively determine what the magnitude of the effect was?
I don't think she got that far, did she?
I mean, she reported that she was seeing a certain percentage of reduction in.
Yeah.
I was wondering.
I don't think she ever recorded anything about taking any gravity.
I think she just published a lot of
She just had that paper she published that
Yeah.
suggested that there should be an effect.
You may be thinking of Podkletnov because he did publish a 2% weight loss.
And I don't remember from the paper, wasn't clear to me what exact mechanism he was using for measuring.
Well, Poher had a little accelerometer on his thing, I think. Dad, do you remember how Podkletnov measured his force?
Well, there were two Podkletnov experiments. The first one was the spinning disk.
Yeah.
The second one was the impulsive electrical experiment that produced, was said to have produced a gravity wave that was collimated that would like disturb a rubber ball hanging on a string in a vacuum, and you could move it to the next building across the street and it would still disturb it. Anyway, that's what they said, although, you know, they never would show a film of it. They were doing it at the Moscow Institute. That's what he did after he left Tampere, Finland, and went to Moscow, and then he published this paper with this.
Where in Moscow? Which institute?
don't remember the exact name. They call it the Moscow Institute, or
It's a materials institute of some sort.
anyway. They had they used a big megavolt Marx bank and a chamber. So I don't know if that one's been replicated by anybody.
I think Poher has the most quantitative measurements in terms of like actual numbers, rather than just looking at the physical deflection that you can see with your eye.
Hathaway did a small experiment. He had a 4-inch disc, but it wasn't a 2-layer or anything. It was just YBCO disc. He didn't see anything. I don't think he used the voltages as high as Podkletnov did either.
Yeah, and Poher was using about 2 kilovolts too.
Yeah.
So it's much lower.
Podkletnov was using about 500,000 volts.
Yeah.
Well, we can, the Poher test that was done at NASA, it was the force was measured with the little fiberglass rod that went down into the liquid nitrogen dewar, and it had a little accelerometer on it, so the vibration that went up the fiberglass rod would read the vibration, and you could get like a force, like thrust measurement off of that.
Yeah, we got in excess of 500 Gs, but we never reproduced the waves that he claimed, except for we did float. We put a second superconductor under the dewar, just in a coffee cup, and we floated a little magnet on top of that, you know, where you levitate a magnet. And when we fired the Poher device, the little magnet, the theory being that if we made a gravity wave by putting electricity through a superconductor, that maybe the inverse would also be true. That if a wave going through a superconductor might produce a current. So if you levitate a small magnet just by the Meissner effect right over a superconductor, that's because there's a supercurrent which is generated by the magnetic field produced by the magnet, which exactly mirrors the field and makes the magnet float. So we thought perhaps if we put that underneath the dewar, very close to it, that would be disturbed. And that actually did happen. When we fired it, the little magnet went flying away. And, you know, we told management about this, but we never saw the waves that he claimed. Now, when you're doing a pulse-powered experiment with 20,000 amps at 2,000 volts, getting the signal is never a problem. You know, you have to shield everything, and you still get a signal. I mean, not even put your input leads into your oscilloscope, you will get a signal, and it will look approximately like your current waveform. So it's not a question of getting the signal, it's a question of getting the right signal. So when we used a double Faraday cage, we did not reproduce Poher signals. However, we did see a whole lot of really strange effects, like the tossing of the magnet and forces coming off the disc. And you pull the disc out, and the disc is unaffected. And if it was a thermal explosion between the layers of the disc, it would have destroyed the disc. But you pull it out, and it was pristine. And we even got a 1,000,000 frame per second movie of a wave coming off that hit one of his emitters. And this wave apparently was what kept blowing up our dewars. They'd blow them all over the place. So we blew up Minute buckets from Walmart after that. Anyway, it was interesting. It's something that, you know, with our institute, maybe we can try to readdress that. But
we talked about funding, and that seems to be the common denominator of all this stuff, is funding or lack of it.
Yeah.
Where is there any money? You know, are you aware of any private money that's being spent on this, or
yes.
Is anybody talking to angel investors or that sort of stuff? Or
let me give you the down low on the funding situation. So you've got your black budgets, that obviously is well funded, and then you have your academic budget, which is non-existent because they think it's hokey, and then you have your random billionaires who have a hobby, okay? And they made their money doing something else, but they are applying their money towards weird anti-gravity stuff just because they want to be known for something other than what they made their money in. So there's a handful of like random billionaires running around who fund these types of things. The Church's Fried Chicken billionaire funded the Hathaway Lab. The American Best Inn and Suites billionaire Robert Bigelow, of course, is Bigelow Aerospace. There are some others that I know of, but we're really trying to address that problem with the institute that we're doing, because I've seen government research, I've seen academic research, I've seen private research, and money is always the problem. The technology is never the problem. The technology is there, and the talent is there. The money is never there. So what we've done with the institute is we've sort of assembled some of these random people with big budgets and a hobby, and we've said, hey, can we like pool money into like a big stable pot of money so that we can have like a safe, well-funded sandbox for people, smart people to play in, and not have to worry about government election cycles affecting their budget, or tenure affecting their budget, or even when you find your billionaire, like sometimes the billionaire runs out of money or loses interest or disappears. So you can't just be dependent on one wealthy investor. You need a big pot of money that's stable, that you know isn't going anywhere. So that's what we're trying to do with the Institute, is just fund the Institute and then pick projects that we think are promising and then fund those. So we're kind of creating like a new vehicle for funding this type of research. That's kind of the approach I'm taking right now.
Is there any possibility of I know it's probably hard if not impossible to do, but crossover between the black world and the illuminated world? That because frequently things move from the illuminated world into the black world.
Yeah, we've
talked
noticed
about that
that
many times.
Yeah.
And they disappear. But I mean, it's to the black world's advantage to keep the illuminated world going, because that acts as a spawning ground for ideas that they might not have in the black world. So it's not necessarily to their advantage to keep it completely segregated. And potentially, since Griffin is now at the pinnacle of the group that controls DARPA, and he has a history that goes through UAH, there would seem to be possibly some fertile ground for some conversation.
Yeah. I've thought about that. the combination of the private and the public-private institution, and then kind of working with the blacker budget.
A quote from Griffin.
A quote from Griffin.
NASA is no longer by any means a research organization.
That is a Griffin quote.
That's a Griffin quote.
Yeah. I imagine there are some strong opinions about Griffin in the room.
Can you tell us about the institutes and where you're located?
Yeah, that's what I want to ask.
Yeah.
Tell us, is it nonprofit? If someone has an idea, a technology, or if they have a basis for science, scientific principles, and they want to come to you, what do they do? What do they get out of it?
Well, so we're trying to make sort of an environment where smart people can gather and experiment with ideas and be rewarded for their intellectual property.
How?
Royalties.
The what? Royalties?
Royalties. Generous royalties.
So you're a corporation, or?
We're a public benefit corporation,
Okay.
which is a newly legislated form of entity, which is kind of like a nonprofit, kind of like a C Corp. So basically we have a public benefit mission, which is the furtherance of public science, in our case. And then we're privately, so a B Corp can take investment and give investors a return, whereas a nonprofit cannot. So since we were trying to attract these like random high net worth individuals, we really wanted to be a B Corp and not a nonprofit, so that we could take their investment and give them a return for their investment. So that's why we're a B Corp. B Corps actually don't exist in the state of Alabama, which is why we're registered in Delaware. Some states have them, some don't. Yeah, so we're planning on negotiating generous royalty rights to the inventor, because you can go over on the arsenal and you can invent for 40 years or 30 years and never see a royalty, even though it was your idea. Or you can come to the Institute and get a generous cut of your own intellectual property. And we, of course, would have the resources to commercialize your...
Yeah, that's the next step. You've got to be able to get someone to
yeah,
manufacture.
we have to get something valuable out of it.
And that's a different entity usually.
Yeah, so we put the resources into funding the research, and we put the resources into making money off of the research, which is commercialization or patent sales or licensing or a variety of mechanisms. And then right now we're closing money to build basically a big facility here in town. So it's going to be about a 100,000 square foot facility, and it's going to have, you know, RF labs and optics labs and a materials lab and a machine shop and spaces that you can rent. If you have a company, you can come rent a space and then share our machine shop, so you don't have to make your own machine shop. We have that already. So it's going to be like a community space where you can actually get some of this research done. And then we'll have funding as well for people. So that's the whole point, is to make it easier for the inventor to invent, because inventors spend so much time worrying about where the next dollar is going to come from, and they shouldn't have to worry about that. They should be thinking about the science and the technology. So that's what we're trying to do.
So where does the money actually come from? From investors in general?
Yeah.
Not contracts?
We'll be doing contracts, but we are taking investment capital right now. Yeah, so we'll have equity investors.
So there are shares. You do have shares, just that.
Yeah.
Okay.
The shares are traded just like a C Corp.
Okay, I know how that works.
Yeah, and it's taxed just like a C Corp. But you just have this public benefit mission, which is, in our case, furthering public science.
And you already have a suite of potentially interested investors?
Yeah, we're closing that right now.
Okay, good.
Yeah, so, yeah, we've got...
ego money. Rich man ego money, right?
Yeah.
That's where it comes from usually.
Yeah. There's some of those random rich people with pet projects that they want to work on. So, but they see the value in the research. You know, they're usually people who, your ideal investor isn't someone that you have to convince that the research is valuable. Your ideal investor already knows that the research is valuable and is interested in giving you money. So you go find those people. You don't try to convince someone who's skeptical. You go to the person who already believes in the cause.
So what about the innovator who's afraid of disappearing?
That's a whole other problem. I think doing it in the public is better in that case. But that's a different...
It doesn't mean it will disappear. Even if you do it in the public, it still don't mean that the inventor won't disappear, for lots of reasons.
Like Ning Lee.
Do you anticipate that once you get your facility up and going and have some creative participation in there, that in itself will give you a good mechanism to go talk to these people that have loads of money? And
oh, absolutely.
I mean,
yeah.
that otherwise it's a lot of drawing on napkins, you know.
Yeah.
And if you've got some physical hardware, physical spaces, enthusiastic participants, that goes much farther toward getting some real funds.
Yeah.
What do you say to an inventor who claims as having ether in space? Ether does exist, and it is extremely high frequency electromagnetic wave. All it needs is to be detected and used as a source of energy. What do you say?
What do I say to that? I would say I believe in ether, and I would be interested in talking about that. Yeah. Tesla believed in the ether. He was pretty smart. I know a lot of people like that too, and I'm interested in talking to more of them, for sure.
Space has permittivity, permeability, and resistance. Permittivity and permeability, you got your inductance, your capacitance. It's got physical characteristics.
Because it's made out of something, i.e. ether?
It's interesting that the form of the equation for the resonant circuit, of RLC circuit, is the exact same equation for the speed of light. It's some constant over the square root of the permittivity and permeability, inductance and capacitance. Same thing.
If you're interested in that kind of thing, there's this guy on YouTube. His name is Ken Wheeler. I don't know if anyone's ever seen Ken Wheeler's videos, but he talks about how it's absurd to say that space is empty because space has properties, which is what you just said. So if you give me your email address or something, I'll send you some of his videos, because he's talking about exactly what you're talking about.
And I'm going to the dinner after the event.
Huh?
I'm going to the dinner after this.
Oh, good, yeah.
Can we get your presentation?
Oh, get the presentation? Yeah, I can send it out. Yeah.
I'll put it out.
Yeah. But thank you all for
Don't forget, subscribe to the channel and bang the bell, because we've got a lot more exciting videos to come here on Galactic Greg's.